Alright, so continuing page 2, so as you get to part E here, when you have a magnitude of a vector and its direction angle, you have everything you need for the vector. It's like face 120 and go out 10 units. Boom, there's your vector. It's 10 units long. Now that's different from the xy component form that we saw in parts A through D. So what if I have the direction and angle and I want the x and y components? Maybe I like that, or it's convenient for things like, especially when you're adding vectors together, when you're finding out how two things influence each other. The quick solution is r cosine of theta will give you the x. Remember this, and r sine of theta will give you the y components of any vector. And so if you take a quick, just plug those in, 10 cosine 120, 10 sine 120. Remember that theta needs to be a direction angle, which it is, from 0 degrees. And the values are -5 and 8.7 respectively that you get from plugging that into your calculator. Now, if this were a no calculator section, which I think it will be on your test, 120 has known cosine and sine values. So the cosine at 120 is -0.5. So when you see that, you could actually do 10 times the cosine at 120, which is -1.5, which gives you the -0.5 or -5 we got. But 8.7 is actually imprecise. That should actually be 10 times the, now sine of 120 is the y coordinate at 120 degrees, and that's the square root of 3 over 2. So 10 times the square root of 3 over 2, or even better, if you cancel that out and call it 5 square roots of 3. So ultimately the exact answer should be -5, and it should be 5 square roots of 3. 8.7 is actually an approximation of that 5 square roots of 3. Okay. And then next page, if I scooch over there, if I can get myself there, flip it over, there we are. Now it says you got an airplane flying at a velocity vector with components 225 and 300. Great. What is the velocity and magnitude and bearing of the plane? So velocity is a vector itself. So to do the velocity vector, we need to actually get a sense of, what it's flying at. That's actually right there. So the vector component of the velocity vector. What's the magnitude of it? When you want to do the magnitude is, this 375 comes from doing the square root of 225 squared plus 300 squared, the two x and y components. Now it's -300 squared, but when you're squaring a negative, it's still positive, and that's where the 375 comes from. And then to do the direction of this, if you draw a little sketch of 225 -300, that means over 225 down 300. So if I ballpark it there, we just found out the magnitude is 375. So that's 375 long. But what the direction should give us, inverse tangent there on your calculator, and I'll type it on mine because I actually don't have it in front of me at the moment. But if I do second tangent of -300 divided by 225, I get -53 degrees, -53.1, which is all good. That's a very nice direction angle and makes sense in the context of my problem. But bearing is to take from north, you want to do 90 degrees in that upper first quadrant, and you want to add to it that 53 degrees down here, and the 90 plus 53.1 is 143.1, or 143. So that's where that value comes from. Okay, that'll finish out page 2, and I'll make a video then for the next pages 3, 4, and 5.